In this session, which is Chapter 3 of Tutorial 86, we're going to thoroughly examine the switching circuit together. You'll learn effective troubleshooting and repair techniques for the switching circuit, enabling you to significantly enhance and complete your understanding of power supply repairs. In the previous tutorial, you completely familiarized yourselves with the VSB circuit. You also learned the troubleshooting and repairs for the VSB circuit, understanding the potential issues it can encounter, and gaining insight into the methods required to effectively address and resolve them. Another critically important circuit within power supplies is the switching section. This is precisely why these power supplies are specifically referred to as switching power supplies. The switching section is an integral part of the power supply designed to immediately shut down the power board if a short circuit occurs, effectively preventing any further and more extensive damage to the power supply circuit. For instance, if there's a short circuit, voltage fluctuations, or any problem arises within the power supply. For instance, if a component burns out during operation, causing a short circuit. This switching system instantly shuts down the power supply, and as previously stated, this is precisely why they are designated as switching power supplies. So where is this switching circuit located on the power supply? Meaning, where on this power board is it and what components does it include? We will cover these topics shortly. But before anything else, it's really best for you to get familiar with the failure symptoms of the switching circuit. When a power supply malfunctions, how do we determine if the fault specifically lies within the power switching circuit? Therefore, I will now proceed to elaborate further on this critical topic for your comprehensive understanding. Alright, so the initial symptoms that usually emerge in switching power supplies directly pointing to an issue within the switching section are as follows. The power supply does not turn on, even though the standby power and the 5V green wire power are present. You see, as you've learned in previous lessons, when you plug a power supply into the electrical outlet, even before you turn it on, the standby circuit should already have 5 volts of power available. This means the purple wire and the green wire must have 5 volts power for the power supply to even turn on. When you test it with a multimeter, you should be able to see a 5 volt reading. If the purple wire doesn't have 5 volts, it means the standby circuit is faulty and it's not related to the switching circuit. However, if you observe that the purple wire provides 5 volts, yet the green wire does not, and the power supply remains unresponsive, it indicates that a particular component or a section of the switching circuit is experiencing a malfunction. The primary symptom of such a failure is the power supply's inability to power on, specifically when the purple wire is indeed supplying the required 5 volts. When you connect the power supply to electricity, always remember to connect it to a test lamp when testing, and then connect the test lamp. In our earlier sessions, you became familiar with how to construct and effectively utilize a test lamp for troubleshooting. When you connect the power supply to the test lamp, the lamp turns on and stays on. In such a scenario, the issue still points to the switching circuit. This, of course, is provided that the bridge rectifier is in proper working order. If you've rigorously tested the bridge rectifier and confirmed its integrity, yet the test lamp illuminates when the power supply is connected, it indicates a malfunction within a component of the switching circuit, most often implicating the transistors as the culprits. These are the transistors that belong to the switching circuit, specifically those located within this particular section here, which I will illustrate in more detail and clarity in the subsequent images. So, if you've plugged in the power supply to your test lamp and confirmed the bridge rectifier is healthy, yet the test lamp illuminates, it indicates a fault within one of the switching transistors. So, which ones are the switching transistors we're looking for? These are the first and second transistors situated on the initial heatsink, right from the circuit's input side, precisely where those prominent large capacitors are located. Observe, when you have the power supply unit in front of you, it contains large capacitors, as you can also clearly see in this image. Correct? Here you'll observe 3 transistors, and one of them, specifically the first transistor on the initial heatsink, was associated with the VSB, that is the standby circuit, which is not our current focus. However, these 2 transistors that you observe right here are integral components of the switching circuit. So, if the bridge rectifier is healthy, but the test lamp still lights up when the power supply is plugged in, it signifies that either one or both of these transistors have burned out, creating a short circuit within the system. Thus, another telltale sign indicating a burnt out or malfunctioning switching circuit is when the test lamp illuminates brightly. Another symptom is that the power supply turns on, but as soon as it does, you hear a continuous whistling sound coming from inside it. Basically, the power supply just starts whistling. Now, this whistling sound might fluctuate in pitch while you're hearing it. Well, the sound, its pitch or intensity might change. But generally, when you hear a whistling sound coming from your power supply, it's actually related to the switching circuit. I'll fully explain this to you later if there's time in this session or in future sessions. This will include exactly which component and section is responsible for that whistling sound and precisely how we can go about resolving this issue. Thus, a whistling sound from the power supply points to the switching circuit. Look, when we say switching circuit, we don't mean just one component. A switching circuit is made up of many components. Just like the VSB circuit was, we need to search and find out which component in the switching circuit has a malfunction, and each component causes a specific type of malfunction, which I will elaborate on later in this discussion. Another common symptom of a switching circuit malfunction in power supplies is that it powers on, operates for a duration, perhaps 10 minutes, half an hour, or even an hour, then abruptly shuts down completely on its own. When you observe a power supply acting in this manner, it indicates that the switching circuit is once again at fault. The switching circuit has a defect and requires troubleshooting to identify the specific malfunctioning component. Of course, you'll learn precisely how to rectify these problems, and once the malfunction within the power supply switching circuit is resolved, these particular issues will no longer occur. Alright, here you'll see a comprehensive image of the power supply unit. This is a complete view of the power supply. I've removed the heat sink so we can see all the components much more easily, and I can give you a better explanation. We won't just talk theory from the power supply itself anymore. Instead, I'll explain everything directly from the power supply board. So, I've removed the heat sinks and now we can see the components much more clearly. Alright, if I were to give a brief explanation, a very short explanation, it would be that the switching circuit includes these transistors that you can observe here. The three transistors, it starts from these capacitors onward. The switching circuit, however, is predominantly made up of these transistors. There are capacitors, and these are the transistors you see here. Specifically, these two transistors are part of the switching circuit. This third transistor, or the first one if you count from this side, belongs to the VSB circuit, which we're not concerned with right now. These two transistors are the switching circuit transistors. Now, another component related to the switching circuit is the two capacitors you see here. This capacitor and this other one, commonly known as start capacitors, we will discuss these capacitors further in due course. Thus, these two capacitors are also integral to the switching circuit, together with the diodes positioned here, as well as the resistor situated right by these capacitors and transistors. Next, the transformer you observe here, which is the middle transformer, is part of the switching circuit. Therefore, if you're wondering which transformer pertains to the switching circuit, bear in mind that the central transformer is indeed part of that circuit, and I will be providing a comprehensive explanation regarding it. The next components that we need to account for regarding the switching circuit are the resistors and the capacitors that are situated in this area. Also, these transistors right here and this IC that you can observe in this specific location are all crucial parts of this circuit. So if we were to trace the switching circuit using its schematic, it would appear as you see it displayed right here, then moving on in this manner and subsequently in this fashion. Overall, you can truly consider a configuration like this to be characteristic of the switching circuit within a power supply. Any component situated within this specific region is part of the power supply switching circuit. Therefore, in the event of a malfunction, we must meticulously troubleshoot those components. Of course, you will learn how to diagnose issues, such as when a problem like the power supply suddenly shutting down arises, or if the power supply whistles, which component is at fault and how to replace and troubleshoot it. Thus, this is in essence the switching circuit. If the power supply fails to turn on, or if it powers up and then immediately shuts down, or if a short circuit occurs causing the test lamp to illuminate, these issues are linked to the switching circuit, which absolutely requires thorough troubleshooting and repair. Now, to provide a clearer explanation and help you better grasp how the switching circuit actually functions, let's consider this scenario. We plug the power supply into the electricity. What precisely occurs from the instant we connect it to the power source? The initial step involves electricity flowing from that point into the capacitors, and subsequently, a branch extends from these capacitors to the pair of transistors you observe here. It's clearly shown by this arrow, and it's also connected to the transistor designated for the VSB circuit. Okay, imagine this black arrow represents the flow of electricity, or more precisely, the voltage that is generated within the circuit immediately after we connect the power supply to an electrical outlet. So, as you can clearly observe, the circuit branches out into three transistors, and from there, specifically from the transistor, it forms a part of the circuit. The VSB also delivers a specific voltage to the IC. This voltage goes to the very IC that you can observe here on the board. When voltage reaches this IC, it confirms that the standby circuit is functioning properly and is in good condition. So with the voltage reaching this IC, the green wire will have 5 volts. This means if you measure the voltage on the green wire, you'll see it has 5 volts. In addition to this, the purple wire also carries 5 volts. However, if for any reason you observe that the green wire does not have 5 volts, while the purple wire still maintains its 5-volt charge. This means you've observed that the purple wire has 5 volts, but the green wire does not. This signifies that the IC itself is indeed faulty. This IC is a pivotal component within the switching circuit, often referred to as the switching IC, and its primary function is to manage the switching operation and power on sequence of the entire power supply unit. This means that when you connect the green wire to one of the black wires, this particular IC is what powers on the circuit and initiates the startup sequence of the main power circuit, effectively bringing the entire power supply to life and making it operational. Therefore, if you notice that the power supply doesn't switch on, meaning it fails to power up, or if the essential 5-volt signal is absent from the green wire, you just need to replace this one IC and the problem should be resolved. In about 90% of cases, the issue lies with this IC. Of course, if the green wire doesn't have the 5 volts, then without a doubt this IC is completely faulty. However, if that's not the case and you've observed that the green wire indeed has the 5 volts, yet the power supply still doesn't switch on or power up, then we can conclude that it's not necessarily related to this IC. In such a scenario, there's a 50% probability that this particular IC is the culprit, while the remaining causes could be attributed to other components which I will elaborate on for you shortly. So it is crucial that you always keep these points in mind. If the 5-volt wire. If no 5 volts on the green wire, this IC is surely faulty. This is assuming the purple wire has 5 volts, but if the green wire does have 5 volts, you need to test other components. If the power supply doesn't power up, then you'll notice the voltage coming this way. So, what exactly happens here? When you connect the green wire to one of the black wires, or for that matter, when you energize the power supply using a power tester, the specific method doesn't really make a difference. No matter how you initiate the power on sequence for the power supply, this IC then transmits a signal directly to these two transistors that are positioned right here. Observe, there are these two small transistors positioned right here, which are typically either the 1015 or the C945 type. The part numbers vary, or it might be a 1020. It truly doesn't matter, there are two transistors positioned here. As I mentioned before, please don't just memorize their exact spots. You might encounter a power supply where these two transistors might be located, for example, here, or perhaps on the opposite side in this area. Alright, the exact placement of these transistors isn't what matters. Here you can see two tiny BJT type transistors that receive their instructions from this IC whenever you initiate the power supply. This is done by either bridging the green wire with a black wire or by hooking the power supply up to a power tester to get it to switch on. The first thing that happens is a command goes from this IC to these two transistors. And what do these two transistors do, you ask? They supply voltage to this transformer. As you can see here, I've indicated it with an arrow. Pay attention to the arrow. Immediately, they send an oscillating on-off signal to this specific transformer, which then processes it. Now, why would it be oscillating, you might wonder? Because when it comes to transformers, if you understand how they work, you'd know that transformers, or simply trans, operate with AC current, and fundamentally, they do not function with DC current. Thus, the transistors situated here are specifically engineered to supply an oscillating AC current to this transformer, enabling it to function as intended. So when these transistors effectively transmit the electrical current following the specific instruction they receive from the IC directly to this transformer. And as a result, what happens? This transformer then sends an alternating current to the gate pins of these two transistors, or to their base pins if they are FET type. It's the gate. However, we won't dwell on its pins in detail as our primary focus here is on repairs. So once this transformer receives the power from these transistors, it then proceeds to deliver the electrical current to the base pins of these two transistors. And so when the bases of these two transistors are triggered, what happens next? These two transistors then apply their voltage to this large transformer.